All right, so we're continuing on. We're on Monday, March 2nd now. So we have these two formulas. Let's use them. Example number 3. I need to find this angle right there. How big is that? I'm going to say, I don't know, 30. 25. Good guesses. Let's figure out what it is exactly. So I guess I can leave the formulas up here. Someone tell me, which formula am I going to be using? Am I using the radians formula or the degrees formula? And then list it out, Julian.
The radians.
The radians. List it out for us.
The circle with the line through it.
It's called
Theta.
theta. Good.
Beta over.
You're just listing the radians one, right? Over 2 pi. Keep going.
Equals the arc length over.
What is the arc length, though? It tells you right up here. 12. Keep going.
Over 2 pi.
And what is R? 6. Yeah, nice. All right, Julian has set up our problem. He knows we're in radians, so that's why he chose 2 pi for the bottom left. Thank you, Julian. So now we have our formula, and now we're going to solve. How are we going to solve? What is our next step here? Colin, Jenny, did you let Andres take your cards again?
No. No. Yes, it's fine.
No?
It's mine and Julie's since you already used it.
This is Andres' card right here, so...
Wait.
Julian, did you... Oh my god, you guys are the worst.
It's a copy.
Sergio, question.
Can you cancel 2 pi and 2 pi?
You can indeed. You can multiply both sides by 2 pi. Essentially is what you're doing. Multiply the right side by 2 pi, multiply the left side by 2 pi, and the 2 pi's are gone. I'm left with theta is equal to 12 over 6. Okay, someone can simplify a little bit further. 12 and 6, those seem like they can be simplified a little bit.
Wait, okay.
Let me see.
Here, you can have it, you can have it. I don't want
I'll take yours too, Sergio. That was a good step. Someone else.
Did you have enough?
Come on, 12 and 6.
Bro.
Yes, Cohen. Divide the top and bottom by 2. Is that what you're saying? Yeah. Okay, divide the top and bottom by 2, and I get 6 over 3. Keep going. Another step further. You want to go again, Cohen?
Divide by 3.
Divide by 3, and you get what over what?
2 over 1.
2 over 1. All right, so what we've... there's lots of crossing out that's happening here.
To make it short. Sorry. Wait.
Is there a... Yeah, Andres.
So to make it shorter, you could have just done divided by 3, right?
I could have just divided by 6 at the very beginning.
At the very beginning?
Like 12 divided by 6 and 6 divided by 6?
Yeah.
Yeah, we could have divided by 6, yeah. So now on the left-hand side, the only thing that we have is theta over 1, so that's just theta. So I'm turning this into theta is equal to, and the only thing that I have on the bottom now, the pi's are gone. Nothing is on the bottom except for 1, so I'm just going to leave it off. The only thing that I have on the top is 2. That doesn't make sense. Theta is equal to 2 degrees?
Yeah, makes sense.
Huh? Yeah.
Are we not?
Oh, it's 2 radians. Yeah, that is about 2 radians. That's right, 2 radians. Just because we don't have a pi doesn't mean it's not in radians. The fact that we don't have any units means it's in radians because the definition of radians is it is unitless. So your answer might not have pi in it even though it's in radians. And that is the final answer. Maybe I need to be clear in my notes about crossing out things. I think the...
No, please be.
Yeah?
Be clear.
All right. The next time I will make sure that is much more clear. Okay, so
Well,
ask me a question on example 3, otherwise we're moving to example number 4. How did you do this step, Mr. Sindel? How did you get from here to here? Where did this number come from? Those types of questions.
what?
All right. Example number 4. Someone set up our equation. What fraction of the circumference is this arc? That's an interesting question. Sergio.
2 pi over 3
2 pi over 3 is the angle.
equals to theta over 2.
Is equal to So this is the theta, right?
Yeah.
So that thing over 360 degrees. But is this in radians or is it in degrees? This angle right here, can you tell if it's in radians or degrees?
Rating.
Radians. So I should be dividing by 2 pi or 360 degrees then?
260.
Not
Two parts.
exactly, yeah, 2 pi. So this is the part, the angle, divided by the entire angle, divided by the entire rotation. And that's going to equal the part over the whole. But that's the thing that it's kind of asking us for. So, Sergio, do you mind doing the right-hand side as well?
I don't know what to do.
Okay. Can someone else help him out? Does anyone have the card? I probably should have waited to call on Sergio. Yeah, Jenny. Don't hold on to your card. Don't take it.
Should know I'm the card thief.
So it's going to be the same thing. I'm asking for the right-hand side, so just list either one of those. They're the same thing.
Wait.
And your notes.
No,
Arc length. All over. And 2 pi r is the exactly, yeah. I'm going to do circumference here instead of 2 pi r, so thank you. So thank you, Jenny. I'll take your card, wherever that is. You're so predictable now. I would be, yeah, anyway, so from here, I need to ask the question again, what fraction of the circumference is this arc? It's asking you, what is this fraction right here? This is the thing that I'm trying to find. So what I can really say here is, this is the thing I'm trying to find, that is x. I'll just treat this whole thing like a variable since that's what I'm trying to find. So I'll say now, x is equal to whatever that thing is, and I'm going to treat this as this is a division symbol, right? So I really have 2 pi over 3 divided by 2 pi. I've just said the same thing. Instead of having it in fraction notation, I wrote it with the division. 2 pi over 3 divided by 2 pi. It's the same thing, just written in a little action.
Would it be over 1?
Oh yeah, so we can treat it as a fraction. We can say 2 pi over 1. I like that, Gunnar. 2 pi over 1, because now it's a fraction divided by a fraction. Whenever you see it, it's always going to be. Quiet raised hand. Who knows our rule? Who knows our rule? Jessica.
I have no idea.
A fraction divided by a fraction. Keep it.
Change it.
Then
Huh?
keep it. Change it. There it is. Yes. So I ran out of room, so I'm gonna have to come over here. So we kept it. 2 pi over 3. We are going to change it. This is not a division symbol anymore. It is a multiplication symbol. And then we flipped it. We take the reciprocal of 2 pi over 1, and that's 1 over 2 pi. And that's still equal to our x.
Really good? Do that.
All right. I need someone to give me my final answer now by cross-canceling a few things that look the same.
Where's that card?
Who has their quiet raised hand? Oh, not very many people to call on. I can only call on that corner over there. I call it the quiet corner. Fernando, Monse, Josie, Eder. Eder, yeah.
Challenge. Not 2 pi.
What about the 2 pi's?
Cancel.
Yes. Chunk, chunk. And my answer is? So what is on the top? What's left over on the top? 1. What's left over on the bottom? There it is. 1/3. Thank you.
So you wouldn't do just 3? Not. It would be 1 over 3, not 3.
1/3. Yep. Not 3.
Oh, 1 times 3 is 3.
1 times 3 is 3. 2 times 5 is 10.
But
It's multiplication.
it's multiplication.
Multiplication. Oh yeah. So with multiplication and fractions, 1 times you multiply the tops. 1 times 1 is 1, so the top is 1. Multiply the bottoms. This is canceled out, so that's a 1. 1 times 3 is 3. Yeah. Multiplying fractions. Multiply the numerators. Multiply the denominators.
So I didn't know that, right?
Cross multiplying only happens when I have an equal symbol on the inside.
Oh.
When I have a multiplication symbol, just multiply tops, multiply bottoms.
That doesn't make sense.
I can go over it again after class if you want to talk to me. Question, Sergio.
Do you think this is real math?
Like to walk your dog.
this is not applicable math. No.
I'll just go do a 360.
So once you guys, well, maybe I can divide some time in geometry to talk about it, but I'd love to talk about why I have to teach you things like this and the Pythagorean. Well, Pythagorean theorem is pretty
Because you
useful.
have to walk you-
I'm trying to think of what's that other theorem, the quadratic formula. Things that I don't want to teach that I have to teach, and things that are
Will that help us
useful.
with our insurance?
All right, so I am now on example number 5. If you guys want to do a little bit of reading, search Lockhart's Lament. We'll eventually be reading that if you stay with Mr. Sindel long enough. So I need to find the length of that arc S. So it's between Fernando, Monse, and
Not just raise it.
If you lay it out,
Raise it. Mr. Sindel, I think
Josie.
we need to explain this a little bit more in depth when we have time in the future so we can actually understand it and use it for
I just want to know why we need
Okay.
that.
All right, yes, Josie, set up our equation, please.
I don't know.
All right, so first of all, it's not very clear, but I'll give you a hint. This is given in radians because 2 doesn't make sense to have an angle that looks like it's 120 degrees. So 2 doesn't make sense, therefore it's in radians. Just list off this formula, but fill in accordingly. Like, do you know that number? You do. Just kind of list this guy off and I'll help you out. Go for it.
2.
It is indeed 2 divided by. Keep going, you got this.
2.
Keep going, yep, 100% correct. Is equal to that arc length, right? And what are we calling that arc length? S, yep. S over, yep, 3.5 goes in for that R, and what goes here and here? The 2 numbers that we need. 2 times pi times 3.5. Yeah, thank you. All right, so now we only have 2 more volunteers left.
Gunner, Fernando.
Does anyone want to tell me my next step voluntarily, or do I need a cold call on one of you?
No. Oh, no.
All right, Monse.
Oh, yeah, you're right.
So Monse, the first step in example 3 is the same first step in example number 5. There it is. Thank you, Monse. So essentially what we're doing is we're saying we're multiplying both sides by 2 pi, which is the equivalent of saying get rid of that 2 pi. So we're really saying multiply both sides by 2 pi, multiply both sides by 2 pi. The 2's are gone, the pi's are gone, the 2's are gone, the pi's are gone.
Being that top 2 is kind of low.
Only one of the 2's can be canceled out at a time. So I have to be careful now. And from here, again, and Gunnar, you can help us out too. Whenever you had an equal sign, do you remember the difference between when we had an equal versus a times?
I got this. Or cross multiply.
Exactly. Yeah, Fernando, can you do the cross multiplication for us? You can cross multiply that way first if you'd like.
So it's gonna be like good 7,
7. Cross multiply the other way.
and then 7 equals S.
So, Mr.
And we're done. Question, Andres.
You would cross multiply when it's an equal sign instead of a multiplication sign?
Yes.
And then when it's a multiplication sign, you have to, what would you do in that situation?
When
Instead of
it's
cross multiplication.
multiply straight through. Yeah, let me put it off to the side.
You get it? I'm curious, right? I want to learn.
All right, so if you have a fraction, so box over box times box, I guess circle over circle, I multiply. This is equal to box times circle over box times circle. But if you have an equal sign, for example, if I have box over box is equal to circle over circle, I cross multiply, go cross and then cross. That is the difference between the two.
All right, thank you, Mr. Schindler. That helped me understand it better.
All right. Well, thank you for asking such a good question.
Well, thank you for being so
Can you
hardworking.
give us a lecture on why we need math to go on to life?
And with our insurance and the taxes. With the quadratic formula.
You know the situation.
To find out
in
the
your head.
speed limit, Gunner.
Yeah, the speed limit of a fraction.
Well, you need to learn how to read to do that, because you just need to read the
Yeah, that's true. Then you're a different breed.
All right. Are there any questions that are related to the lesson? Yes, got it. All right. So, give me your fist of 5 on both of these two parts. Converting between degrees and radians was part 1, and then part 2 was solving problems relating central angle, circumference, and arc length. Fist of 5, go. I'm seeing a 3, a 4, a 3, a 4, a 3. I'm doing only full numbers. A 2, a 3, a 3, a 3, a 2, a 3, and a 3. All right.